Hello everyone. Today we are going to start with a new topic, error function, which is actually pretty much useful in physics, also to compute results with high probability as well as with lower probability. These functions can be used. So let's start with the definition. Mainly two definitions involved in this section. The first definition is error function definition. Error function is defined as ERF of x, this is a notation for error function, and is equal to 2 over root pi integral 0 to x e to the power minus u square du. Please note that whatever function you are using here, the same thing as a upper limit we are going to use. Okay, so error function definition is given by this. The next pretty much important definition is complementary error function. The complementary error function definition is given by 2 over root pi 0 x to infinity e to the power minus u square dx. So error function, and the next definition is for complementary error function. The notation for complementary error function is ER as it is and C for this complementary. And similarly, whatever function I'm using here, it uses as lower limit in the definition. Okay, and there is an alternative definition for error function which I can develop here. The alternative definition this is given by when I'm substituting u square as equal to t in the definition of error function. So when you are substituting u square is equal to t, so what is du? 2u du is nothing but dt. So du is equal to 1 over 2u dt. So that is nothing but 1 over 2 times u is square root of t. So I can use this square root of t dt. And let's see what are the limits here. Limits are nothing but for u I'm having limits 0 to x. So for let's say for t, when I'm substituting u is equal to 0, t is also 0. When I'm substituting u is equal to x, in that case t is x square. So new limits are 0 to x square. So what is the new alternating definition for error function? Is nothing but 2 over root pi 0 to x square. Now e raised to, in that case what we had e raised to minus u square, so now this is e raised to minus t into what is du is root t dt. So the definition becomes 2 get cancelled, 1 by root pi 0 to x square e raised to minus t into t 1 by t raised to half, I can write it as t raised to minus half dt. Correct? So this is my alternating definition for error function. Similarly, I can just figure out what must be the alternate definition for complementary error function. Do the same procedure and I can prove that the alternate definition for complementary error function is 1 by root pi x square to infinity e raised to minus t into t raised to minus half dt. Okay, by using similar substitution I can prove the same thing. Okay, proof is not important, just keep in mind the alternate definitions here. Okay, and so in the next video we are going to start with solving properties of error function one by one. and then we will solve some examples based on this.